Hello students. In the previous video, we have studied about electric charge and its SI unit, electric current and its SI unit, and electric field. Before moving to the next concept, we will study about some more important points related to electric charge and electric current. So, some important points to remember are: first, charge on an electron, which is equal to minus 1.6 into 10 to the power minus 19 coulomb. You know that SI unit of charge is coulomb. This negative sign indicates that electrons are negatively charged, and this is the numerical value of the charge present on an electron. Similarly, charge on a proton is plus 1.6 into 10 to the power minus 19 coulomb. Easy? Now, third point is the smallest charge which can exist independently is E, is denoted by E, whose value is 1.6 into 10 to the power minus 19 coulomb, which is same as that of the numerical value of electron or a proton. Only numerical value, no sign. No. What does this mean? So this word is important. Independently. It means that the smallest charge which can exist in nature, which are available in nature, has a numerical value 1.6 into 10 to the power minus 19 coulomb, and is independent. It does not depend on other things. So if we want to transfer a charge from one body to another, the minimum charge we can transfer is this. Okay? Now, fourth point. SI unit of electric current is ampere. But there are other units as well in which we can measure it. One is 1 milliampere. It is small m and it is capital A. 1 milliampere. It means 1 milli means 10 to the power minus 3 ampere, which is 1 by 10 to the power 3 ampere. Understood? Again, fifth point, 1 microampere, which is 1 microampere. Now, micro is the symbolic form of micro is this, which is equal to 10 to the power minus 6 ampere, which is 1 by 10 to the power 6 ampere. So these are smaller values of current. Suppose 5 milliampere. So it means 5 into 10 to the power minus 3 ampere. Or 5 microampere. It means 5 into 10 to the power minus 6 ampere. Now the last point to remember is, you know, in solids, current flows due to the flow of electrons. But what is the direction of current? Suppose this is a solid. It is connected to cell. Now in this solid, electrons are flowing from this point to this point. Okay? The current will flow in the opposite direction to the flow of electrons, which means if the electrons is flowing from this point to this point, the current will flow in this direction, from this point to this point. Have you understood? the direction of current is opposite to the direction of flow of electrons. The direction of current is opposite to the direction of flow of electrons. Next topic is quantization of charge, which is one of the important property of charge. The formula which will come later in this topic will be important for numericals, so please pay attention. Quantization of charge. Before explaining the whole topic, let us see the meaning of this word quantization. It means available in fixed values or discrete values or amount. I will explain you with an example. Suppose you want to buy a pen or pens. You will go to a stationery and ask the shopkeeper to give one pen, or you want 10 pens, then please give 10 pens. You can't ask for 1.5 pens or 2.5 pens. So the amount is fixed, which means either 1, 10 or whatever amount you want. It will not be half or 1.5. That is known as quantized. Now let us see which are the things which are not quantized, like food we are eating. Suppose at home you want to eat apple. You can eat 1 apple, 2 apple, or even you can eat half apple. It doesn't mean that you always have to eat 1 full apple or 2 full apples. You can eat half apple or even 1.5 apples. So these are not quantized. Have you understood? Now quantization of charge. It means that every charge, whether it is 1 coulomb or 1000 coulomb or 10,000 coulomb or whatever charge it is, every charge is an integral multiple of basic unit of charge. It means that suppose there is a charge Q. It is an integral multiple of n. Suppose n denotes any number. 1, 2, 3, 4, 5, 6, 7, 8. It goes on. It is an integral multiple of basic unit of charge. This is basic unit of charge. Now we have studied about this basic unit just previously, which is E is equal to 1.6 into 10 to the power minus 19 coulomb. Okay. I will write the concept. Every charge is an integral multiple of basic unit of charge. This is the basic unit of charge. Okay. Now this basic unit of charge is also known as fundamental charge. What it is known as? Fundamental charge. Now, it means that suppose you want to transfer a minimum charge from one body to another. So what you will transfer? You will transfer E. I told you what is the minimum charge that exists? E, which is equal to 1.6 into 10 to the power minus 19. So minimum charge we can transfer is E. Either it can be positive or negative. The value of E is 1.6 into 10 to the power minus 19 coulomb. It means that it is 1E and minus 1E. The next bigger value of charge is plus 2E or minus 2E. Then again plus 3E or minus 3E. It can go on. The number can be 3, 4, 5, 6, 7, 8, 9. It goes on. And minus 3, minus 4, minus 5, it can gone to the negative value, whichever infinity value. So in general form we can write plus minus Ne. This is quantization of charge. Here we will write plus minus, and this is the formula for quantization of charge, where N is equal to 1, 2, 3, 4, it goes on. Plus sign indicates that it is positive charge and negative sign indicates that it is negative charge. So once again, every charge is an integral multiple, which means n, of basic unit of charge. Have you understood? Every charge is an integral multiple of basic unit of charge. This is known as quantization of charge. You will understand much better after doing a numerical. So we will do a numerical now. The numerical is given on page number 200 in your NCERT book. So all of you open page number 200 and read the numerical. Calculate the number of electrons constituting 1 coulomb of charge. I told you that the formula of quantization of charge will be used to solve many numericals. This is one of the numericals. Now, as you know, the formula of quantization of charge is Q is equal to NE. Now, we will use this formula to solve this numerical. Now you can see, calculate the number of electrons. It means we have to find out N, number. I told you N indicates a number, 1, 2, 3. How many numbers of electrons are there? And we have to find out. Okay? Constituting 1 coulomb of charge, which means the charge is given, Q is given. Q is what? 1 coulomb. Is it? Now, what is the value of E? We have already studied. It is a fundamental unit or a basic unit of charge, which is E is equal to 1.6 into 10 to the power minus 19 coulomb. We will substitute all these values, Q, E, and we will find out N. Q is 1 coulomb and we have to find out into, what is E? 1.6 into 10 to the power minus 19 coulomb. Okay. Now, N will be equal to 1 coulomb upon 1.6 into 10 to the power minus 19 coulomb. Okay. Now, 10 to the power minus 19, when it will go in the numerator, it will become 10 to the power 19. Now, when we solve this, 0 will come here. After solving, the answer will be 10 to the power 19, which is equal to 6.25 into 10 to the power 80. There will be no unit. Why? Because this is a number. It means that this many number of electrons should be transferred so that 1 coulomb of charge, we will get 1 coulomb of charge. Once again, this many number of electrons, which is 6.25 into 10 to the power 18 number of electrons, we have to transfer to get 1 coulomb of charge. Now we will learn about electric potential and electric potential difference. Let us start with some general knowledge. I think many of you will know that we are receiving 220 volt supply, electrical supply through wires at our home. Also, there are cells available like this in the market, which are of 1.5 volt, 5 volt, 9 volt or even 12 volt, which we use to run electrical appliances like TV remotes or AC remote or wall clock, etc. etc. What is this volt? This volt is actually electric potential difference. We use a general term at home which is voltage. Voltage is nothing but electric potential difference. Now, how can we understand electric potential difference or electric potential through this cell? Now you can see a cell has a positive part and a negative part. So there is a difference in this positive and negative part which allows the current to flow through the wires or through the circuit. Now, if there is no difference, only positive part is there, no current will flow. If there is only negative part, no current will flow. We need both positive and negative. What are these? Positive and negative are individual potentials, which are known as electric potential. This part has its own electric potential and this part has its own electric potential. When we subtract these two, we get electric potential difference. And because of this electric potential difference only, the current flows through the wires or through the circuits of TV remotes or wall clocks. Have you understood the basic concept? Now we will go towards the definition of electric potential and To define electric potential, we need to know about electric field. We have studied about electric field in the previous video. It is the space or region around a charge in which its force can be experienced. We will use that concept to define electric potential. Let us see how. We will consider a charge plus Q. Now, this charge will have an electric field around it, a space or region in which other charge can experience a force. This is the electric field of this charge. Now we will take 2 points, one outside and one inside this electric field. Let the point inside be A and the point outside the electric field be B. This B is situated at infinity. Why? Because we don't know where it is. So we will say the B point is at infinity. At B, there is a charge which is plus 1 coulomb. Plus 1 coulomb means it is positive. Its value is 1. So we can say it as unit charge, unit positive charge. Okay. Now, there is a charge, there is a electric field, there is a point inside and there is a point outside. There is a charge plus 1 coulomb which is known as unit positive charge. Now we will define it. See, electric potential at a point inside the electric field of a charge is defined as work done in bringing a unit charge, unit positive charge from infinity to that point inside the electric field. Okay, not understood, I know. Now, when we bring a unit positive charge plus 1 coulomb from B point to A, we have to do some work. That work is equal to electric potential. Now you understood? Now, we have to bring that plus 1 coulomb from infinity to point A, which is inside the electric field of that charge. That work done is equal to electric potential. I will define it once again. You can write this definition in your notebook copy. Okay? So, while I am saying it. Okay? Once again. electric potential at a point inside the electric field of a charge is defined as electric potential at a point inside the electric field of a charge is defined as work done in bringing a unit positive charge from infinity to that point inside the electric field. Have you understood? Now I will define electric potential difference in the same way I defined electric potential. There is only a little difference. Let us see. Here also we will consider a charge plus Q. There will be an electric field around it. This is the electric field around it, space or a region around it. Now, here we considered 2 points, one inside and one outside. Here also we will consider 2 points, but both will be inside. Okay? Let it be A and this point as B. Here also we will consider another charge plus 1 coulomb, which is unit positive charge. Okay, again there is a charge, there is an electric field of that charge, there are 2 points, both the points are inside the electric field, there is a unit positive charge at one point. Now we have to move this charge from one point to another. So to move this charge we have to do some work. Suppose we are moving this positive test charge from B to A. To move this positive test charge from B to A, we have to do some work. This work done is equal to electric potential difference. Now, I am defining it properly. You can write in your notebook, okay, while I am saying it, okay. Electric potential difference between 2 points inside the electric field of a charge is defined as electric potential difference between 2 points inside the electric field of a charge is defined as work done in moving a unit positive charge, from one point to another inside the electric field. Now I am defining both these definitions once again together so that you can understand in a much better way. So listen properly. Electric potential at a point inside the electric field of a charge is defined as work done in bringing a unit positive charge from infinity to that point inside the electric field. Now, electric potential difference. Electric potential difference between 2 points inside the electric field of a charge is defined as work done in bringing a unit positive charge from one point to another inside that electric field. Electric potential difference is represented by capital V. By definition, electric potential difference is equal to work done per unit charge, because electric potential difference is the work done in moving a unit positive charge from one point to another. So therefore V is equal to work done upon charge, work done per unit charge. So this is the formula for electric potential difference. SI unit of electric potential difference is watt. Volt. We will define 1 volt using this formula. 1 volt will be equal to work done. V is equal to 1 volt. Then work done is 1 joule and charge is 1 coulomb. Now we will define. See how. Electric potential difference between 2 points inside the electric field is said to be 1 volt. When 1 joule of work is done in moving a charge of 1 coulomb from one point to another inside the electric. Ammeter is a device used to measure current in the circuit, current flowing through the circuit, and voltmeter is a device used to measure electric potential difference between 2 points in the circuit. At your home, you can see several electrical appliances connected to switches, and then they are connected to mains. So when you are putting on a switch, you can see various electrical appliances start working. This is an example of electric circuit. But how will you define an electric circuit? An electric circuit is a closed continuous path which is made up of electrical components such as electric bulb, battery, key, etc., through which the current is flowing. Once again, electric circuit is a closed continuous path made up of electrical components such as bulb, batteries, keys, switches, etc., through which the current is flowing. Now we will draw a simple electric circuit. We can use copper wire for connections. Suppose this is a bulb. This is a copper wire which is used for connection between various electrical components. Now this is a cell. This big line indicates positive terminal and this small line indicates negative terminal. Then we can connect a key which should be closed. Closed means we should on the key, and we can connect an ammeter which can measure electric current flowing through the circuit. Now ammeter should always be connected in series. Okay. Another thing we can connect here, which is voltmeter. It should be connected across 2 points because voltmeter is used to measure electric potential difference which is across 2 points. So suppose this is 1 point, this is 1 point, we can connect a voltmeter across it like this. So voltmeter will measure electric potential difference, ammeter will measure electric current flowing through the circuit. Okay, so this is a simple electric circuit. One of the main points you have to keep in mind that it should not have any breakage. There should not be any gap in the circuit. Why? Because if it is not continuous, the current will not flow. Hope all of you have understood all the topics which we have discussed today. Please revise all the topics. If you have any doubt, please bring it to us when the school starts. Thank you and have a nice day.